Welcome to TEKS Tuesday. Shadows, Seasons, and Moon Phases, brought to you by
the Austin Nature and Science Center.
Hey, why are these guys following us?
I know why. The sun creates our shadows, and they don't always look the same throughout the day. They change in length as the day goes by.
So you're telling me that my shadow gets shorter and taller, but I don't?
Exactly. The sun rises in the east, and it sets in the west, and at about noon, it'll be directly above our heads, and that's when our shadows will be the shortest.
So does that mean that I could tell what time it is based on looking at my shadow?
You're definitely onto something, James. Even though we can't tell the exact time using just our shadow, we can use a sundial in our shadow to do just that.
And I wish we had one of those so we could see.
I think you're gonna like this next part.
How did we get here?
Where are we? We're at the Austin Nature and Science Center's very own human sundial. This is where we can use our shadows to tell the time.
Wow.
I heard that sundials were used to tell time back in the day.
Oh yeah, and that's before they had clocks that they could tell what time it was based on looking at a sundial.
You're right. This is a special type of sundial called an analytic sundial.
Every sundial has something in the center that casts a shadow, and that thing is called a gnomon. An analytic sundial has a vertical gnomon and hour markers positioned in an elliptical pattern. The gnomon is not fixed and must change position daily to accurately indicate time of day.
I wish I was a gnomon.
I think you can be.
Let me give it a try.
This is where I would stand if the month were January, February, March, April, May, June, July, August, September, October, November, and December.
Look, your shadow's being cast on the dial plate. Nice vocab. The dial plate is the surface that your shadow's cast onto. So why does the sun appear in different places in the sky during different seasons? So glad you asked. The answer is the tilt of the Earth's axis.
The tilt of the Earth's axis causes seasons?
That's right.
So that must be why the days feel longer during the summer, because the sun has more hours in the sky. During the winter, it feels like the days are shorter, and the sun is actually in the sky for a smaller period of time.
So the first day of winter here in Texas is December 21st, the winter solstice. It's the shortest day of the year. The longest day of the year is June 21st, which is the summer solstice, and the first day of summer. We also have September 21st, which is the autumnal equinox, and it is the first day of fall, and March 21st, the first day of spring, called the vernal equinox. But I'm just kind of confused how the tilt of the Earth's axis actually causes seasons.
Winter, spring, summer, and fall are all caused by the tilt of the Earth's axis and by the elliptical shape of Earth's orbit. We live in the northern hemisphere, so we experience summer, the hottest season, when the Earth's axis points towards the sun, with the North Pole facing the sun as directly as it ever does. Winter is the coldest season because the Earth's axis in the northern hemisphere points away from the sun at this time of year. Between these two extremes, we experience spring and fall. These seasons occur when the Earth's axis points 90 degrees away from the sun.
Wait a minute. So all those countries south of the equator, they must be in a shadow down there. How can it be summer?
Well, I learned something crazy when I went to Australia. It's not summer there. When it's summer here, it's winter down there. All this talk about shadows really reminds me of something, but I can't quite put my finger on it. I think I know what you're talking about, and it's the moon. No big deal, but I'm kind of a moon expert.
This is the sun. This is what one day looks like, a rotation. This is the Earth revolving around the sun, which takes 1 year. The Earth is rotating and revolving. This is the moon orbiting the Earth that takes 28 days. As the moon revolves around the Earth, the sunlight hits the moon at different angles, creating the moon phases. It appears as if the moon is getting bigger. This is what a full moon would look like in the sky. This is what a waning gibbous would look like, half moon, waning crescent, and full moon where you can't see it at all. This is a solar eclipse when the moon blocks the sun's light. This is a lunar eclipse when the Earth blocks the sun's light on the moon.
Wow, I wish I could go there.
I think you're gonna like this next part. See you next time.